Technology plays a vital role in modern operations, supply chain management, and organizational competitiveness. Effective technology initiatives begin with a clear understanding of business requirements and operational objectives. Supply chain professionals participate in developing system requirements and technical specifications to ensure technology solutions support organizational needs. Requirements gathering involves identifying process objectives, user expectations, data requirements, reporting needs, integration requirements, and performance criteria. The objective is to translate business needs into functional and technical specifications that technology providers can implement successfully. Well-defined requirements reduce implementation risks, improve user adoption, and increase the likelihood that technology investments will deliver measurable business value while supporting strategic and operational goals. A critical step in technology planning is evaluating the current state of organizational processes and comparing it with a desired future state. Organizations use tools such as process mapping, value stream mapping, workflow analysis, gap analysis, and capability assessments to understand existing performance levels. The current state assessment identifies inefficiencies, bottlenecks, redundancies, and technology limitations that restrict performance. The ideal state analysis defines the future operating model required to support strategic objectives and competitive priorities. Comparing the two conditions enables organizations to identify improvement opportunities and establish realistic implementation roadmaps. This structured approach ensures technology investments address genuine business needs rather than simply replacing existing systems with newer technology. Gap analysis helps organizations identify system limitations, resource requirements, process deficiencies, regulatory obligations, and organizational constraints that may affect technology implementation. During this process, managers evaluate data quality, employee skills, infrastructure capabilities, integration challenges, and compliance requirements. Financial considerations include acquisition costs, implementation expenses, training investments, maintenance requirements, and expected returns. Organizations must also assess process knowledge requirements and determine whether internal expertise is sufficient to support implementation efforts. Regulatory requirements related to data security, privacy, quality management, and industry standards must be incorporated into system design. Comprehensive gap analysis provides a realistic understanding of implementation complexity and supports informed decision-making regarding technology investments. The decision to acquire new technology involves evaluating numerous strategic and operational factors. Organizations often pursue technology investments to improve efficiency, enhance visibility, reduce costs, increase responsiveness, improve customer service, or gain competitive advantage. Other considerations include scalability, cybersecurity risks, vendor reliability, implementation complexity, compatibility with existing systems, and long-term support requirements. While advanced technologies may offer significant benefits, they also introduce risks associated with disruption, employee resistance, integration difficulties, and financial commitments. Decision-makers must evaluate both tangible and intangible benefits while considering organizational readiness and strategic alignment. Successful technology acquisition decisions balance innovation opportunities with risk management and resource availability. Achieving the desired future state requires disciplined project management, clear ownership, and effective resource allocation. Organizations must establish measurable objectives, assign responsibilities, define milestones, and monitor progress throughout implementation. Project management tools, such as work breakdown structures, Gantt charts, critical path analysis, risk registers, and status reporting systems, help coordinate activities and manage resources effectively. Stakeholder communication is equally important because technology initiatives often affect multiple departments and business processes. Organizations must also evaluate trade-offs among scope, cost, quality, and schedule to maintain project feasibility. Effective governance ensures accountability and helps keep technology initiatives aligned with business objectives, while minimizing implementation risks and operational disruptions. Technology implementation requires rigorous testing to ensure systems function as intended before deployment. Testing activities typically include unit testing, integration testing, user acceptance testing, performance testing, and security validation. Organizations must verify that new systems support business processes accurately, maintain data integrity, and integrate effectively with existing applications. Restrictions on existing technologies may also need to be considered during implementation to avoid disruptions and compatibility issues. Thorough testing reduces the likelihood of operational failures, minimizes user frustration, and improves confidence in the new solution. A structured testing strategy helps organizations identify defects early and implement corrective actions before systems become fully operational. Once technology systems are implemented, ongoing maintenance becomes essential to sustaining performance and reliability. Organizations must prioritize maintenance activities based on business impact, risk exposure, system criticality, and resource availability. Effective communication between technology teams, business users, and leadership supports timely issue resolution and continuous improvement. Master data integrity is particularly important because inaccurate data can undermine planning, forecasting, inventory management, procurement, and financial reporting processes. Data governance practices establish ownership, standards, validation procedures, and maintenance responsibilities. By maintaining accurate master data and implementing disciplined maintenance processes, organizations ensure technology systems continue supporting operational effectiveness and informed decision-making. Enterprise Resource Planning (ERP) systems serve as integrated platforms that connect core business processes across functions such as finance, procurement, manufacturing, inventory management, sales, and human resources. ERP systems provide a single source of data that improves visibility, coordination, and decision-making throughout the organization. Advanced Planning and Scheduling (APS) systems extend ERP capabilities by using sophisticated algorithms to evaluate constraints, optimize resource utilization, and develop feasible production schedules. Emerging technologies, including artificial intelligence, machine learning, predictive analytics, cloud computing, digital twins, Internet of Things, IoT devices, robotics, and automation, further enhance organizational capabilities. When applied strategically, these technologies improve responsiveness, efficiency, visibility, and competitive advantage while supporting continuous innovation and operational excellence.